Then this is the BFSK receiver. So in the receiver, as I told, coherent BFSK receiver means coherent in the sense synchronization. So we have to produce the carrier signal which we have introduced in the transmitter. So whatever you have given us the carrier input, that has to be applied in the receiver section also. So we need to synchronize transmitter carrier frequency with the receiver carrier frequency. So the input for this receiver is BPSK signal S of t. Here in the multiplier, we are applying the carrier frequency for synchronization. So this is called as input integrator. So the integrator receives some multiplication of BPSK signal along with the carrier frequency. Okay, then the integrator will produce two input signals, S1 of t and S2 of t. So the multiplier along with the integrator, this entire setup is called as correlator. Here this is called as the correlator 2. Then this decision device. So this decision device is represented as Y of t. Decision device will choose either 1 or 0. So this is producing 1 for Y of t greater than 0. That means whenever the binary input signal is 1, in that case the outcome is going to be 1. Similarly, in the threshold level is less than 0, then Y of t must be less than 0. So two bit streams are reproduced here. So in this way we can recover the original signal. So this is coherent BFSK. Similarly, non-coherent BFSK receiver, we have to use band pass filter to eliminate the unwanted frequencies. So this band pass filter will allow only FH. Here only the low frequency signals are going to be allowed. So envelope detector. From the envelope detector name itself, the envelope of the outcome of this band pass filters, we can able to retrieve our original signal. Here also the same condition. The comparator. Again this comparator will compare the envelope detector outcome with the threshold level. If it is greater than 0, then the outcome is going to be 1, otherwise it is going to be 0. So this is BFSK receiver in terms of non-coherent reduction. Then geometric representation of orthogonal BFSK. So we know that FH is equal to M into FB. Similarly, low frequency is equal to N into FB. So pi 1 of t we have already derived, root 2 divided by TB cos 2 pi FH. Similarly, pi 2 of t which is equal to 2 divided by TB cos 2 pi N FB. So SH of t is nothing but root PSTB into 2 divided by TB cos 2 pi FHT. SL is equal to the same thing. The only difference is low frequency signal FL is considered. So FH is equal to, we know that F0 plus omega divided by 2 pi. FL is equal to F0 minus omega divided by 2 pi. So this can be replaced as pi 1 of t and pi 2 of t. So Sn of t is equal to root of PSTB when you are replacing this as this. Similarly, SL of t is equal to PSTB into pi 2 of t. This is the signal representation of BPSK signal. So this is the decision boundary. If the signal is greater than 0, then it is considered as it's plus 1 value. If it is less than 0, it is considered as minus 1 value. The distance between SL of t, SH of t can be obtained with the help of this triangle. So the distance d is equal to root 2 PSTB. So when we simplify this, it is equivalent to 2EB. That is PS into 2EB is considered as Euclidean distance EB. For our simplification, this is replaced as EB. So d square is equal to opposite divided by hypotenuse. So PSTB the whole square plus root of PSTB the whole square. So when you simplify this, we will get root of 2EB. What is the advantages of BPSK? The main advantage is easy generation. Disadvantage, bandwidth is higher than 4 FB. Distance between the signals is very less. Probability of error is more, because if we go for non-coherent non-coherent detection, the probability of error will be more because we are not considering the carrier recovery. So only the envelope, based on the envelope we are predicting the signals. So the input signals are either 1 or 0. So most error occurrence will happen due to this. So error probability of BPSK. The signal space is drawn in between pi 1 of t to pi 2 of t. R1, R2 are the distance from origin to first level, and here origin to 0 level. So the distances I've already told you, PS, TB is present in between this. So for both SH of t and SL of t, R1 is equal to root PST by R2 is equal to 0, where SH of t is transmitted. Similarly, R2 is equal to root PSTB, for SL is transmitted, R1 is equal to 0. So from this conclusions, we can say that sigma naught square is equal to n naught by 2 plus n naught divided by 2. So this is equivalent to n naught. Okay. So this is the power spectral density. So we are obtaining the n1, n2 noises with respect to R1 and R2. So if we apply this in the power density function, n of t will be equivalent to this equation. So the probability of error is nothing but fx of n naught of t, that is the noise power density function along with the distance vector. So if you integrate this and simplify the previous equations with respect to t, we will get the error probability as 1 divided by 2 pi n naught integral 0 to infinity e power minus y square root of 2 n naught into dy. So when we simplify this equation after substituting the limits, the error probability of BPSK, it leads to 1 by 2 error function of root of PS into TB divided by 2 n naught. So here we are simplifying the above equations as ERFC, that is the error function, for our simplification. So PE of, that is error probability of BPSK, is equivalent to 1 by 2 ERFC root of EB divided by 2 n naught. Similarly, for non-coherent BPSK, this is equivalent to 1 by 2 into e power capital E divided by 2 n naught. So let us consider an example problem. Here the amplitude of the input at coherent optimal receiver is 10 millivolt, frequency is 1 megahertz. The signal is computed with white noise of PST. Data rate is given. Calculate the probability of error. So magnitude is given, the probability of error is given, TB is given. We have to obtain PE of the signal transmitted. So n naught is equal to, substitute the given RB value, we will get n naught from this. So EB is equal to, we know the formula, PS into TB. So A square divided by 2 into TB. So the values of power density function is substituted. So this leads to this, and probability of error, we have the formula, substitute the values, we will get PE. Thank you.